And one of those things that synthetic division can't do is divide by something of degree higher than 1. So if I'm given something like this problem, x to the third plus 5x squared plus 5x minus 3 divided by x squared plus 3x minus 1. I can't do that with synthetic division without really, really suffering. I'd have to use the quadratic formula on this to get two irrational roots, and then I'd have to divide the irrational roots into that polynomial. That's just horrible. I really, really don't ever want to go near that. Instead, I'm going to do long division happily here. X to the third plus 5x squared plus 5x minus 3. And say, okay, what do I have to multiply this by to turn it into this? LJ? An x. Okay. And then x gets distributed to each of these. X to the third plus 3x squared plus x. What's up? It's a negative what? I'm sorry? A negative 1 here. Oh, okay. Good catch. So that's going to be a negative 1x. And then we subtract. We've got 2x squared minus a minus is a plus. And then I bring down my minus 3. And what do I multiply this by to turn it into this? That's going to be a 2. And 2x squared plus 6x minus 2. And when I subtract, I get negative 1. And remember, in the past, we've probably written our answer as x plus 2 plus that remainder of negative 1 over our divisor, 3x minus 1. This is called our quotient. And we know the quotient is the result of dividing. This year, though, your textbook is going to ask you for some of the problems to write this in a different format. And to exemplify the different format, I want to show you a very simple problem, 5 into 17. And 5 into 17 goes 3 times with a remainder of 2. And so we might think to write this as 3 2/5 as our quotient. And it certainly is our quotient. But your book is going to ask you for some problems. They're going to state in the direction, please write the answer in the form of quotient times divisor plus remainder. Divisor times quotient plus remainder. And so for this problem, we're going to have 5 times 3 plus 2. This is the format they're going to want some of the answers written in. Divisor times quotient plus remainder. So if we go back to this problem that we just did here, my divisor was this, x squared plus 3x minus 1. My quotient was x plus 2. And my remainder was a minus 1, as I recall? Yes. And so they'd want to see the answer written like this. Okay. So watch out for those directions that specify a form for the answer. This is divisor times quotient plus remainder. Not all the problems come with those directions, and the ones that don't, you're more than welcome to continue what you were doing in the past and writing this kind of a solution, where you just write the quotient plus the remainder over the divisor. This is quotient plus remainder over divisor. Okay. So if it doesn't specify and you prefer this method, by all means use this method. Okay, so one thing that I can't do with synthetic division is I can't divide anything of a higher degree than 1. You can only use linear factors with synthetic division. But there's a second problem that comes up with synthetic division, and that's when I have something like this problem. Let's take a look. Where is? I saw one earlier. Okay. So let's say this is our polynomial, and we want to divide by this. Okay, so what do I use for synthetic division then? Shannon? Not -1. I would use -1 if this were my factor. -1/2, that's right. I'm always using the x-intercept with synthetic division. I'm not using this, this value by itself. Okay, so if I do this with synthetic division, I get -1/2, 2, -8, 7, 6. I bring down that 2, I multiply, I add, I multiply, 9/2. 14/2 plus 9/2 is 20. That didn't work. Why did that work? Where was my mistake in the FOIL? Did you catch it? Sorry, say it again. Here. Okay. So that's -9. Okay. So -1 minus 9 is -10. And now when I multiply, I get 5. That's much better. And now we have a 12, and we get -6, and we get 0. So accordingly, this polynomial is 1 degree less than the third degree polynomial we started with. See, we had 2x to the third to start. We divided by 2x plus 1, so now we're down at 2x squared minus 10x plus 12. This you can take out a 2 with our GCF factoring. And then this factors as x minus 3, x minus 2. But here's the problem with synthetic division. Remember what we started with? Now, what's going to happen if you distribute here? You're going to get 4x plus 2 times x minus 3 times x minus 2. And I hate to say this, but 4x times x does make x to the third, but does it make 2x to the third? Oops. That's a problem. Now, it's kind of a not real problem, because this isn't what she told me to divide with. Hey, Shannon, what did you tell me to divide with? -1/2. So let's change this factor then to be this -1/2 thing. X plus 1/2 times 2 times x squared minus 5x plus 6. Now, if we distribute this, we end up with 2x plus 1, just like we started with. But a lot of people forget this, that they should be using this times that common factor, and they end up slapping this thing tack on in front of what they just got, and then if we FOIL it out, we don't get back to the original. This is a common issue on the quiz next week. So I think that I love synthetic division. It goes really fast, but I find there are two serious drawbacks to synthetic division. One, I have to really watch out when I have a coefficient here in front of x, both in building what my divisor should be, said Shannon, but also when I'm done with that division and I think I've got this polynomial, if I just go back to my original factor, this times this isn't going to give me my original polynomial. I really have to use that form times that GCF to get that. And that's really tough for people to remember, especially in the midst of a quiz. So watch out for that, and of course, in situations where we're given something that's not linear to divide into a polynomial, I'm definitely going to be using long division then. Ooh, there was one other thing I wanted to talk about before we got to number 3, and that is this. Yeah, I saw Jason showed us that he could write plus and minus root 3 as x minus root 3 and x plus root 3. And then Ryan said that he actually preferred using the FOIL form of this, of x minus 3. Well, I kind of want to go through synthetic division with these radicals and see what that's like. Ryan got us as far as this, which would be x to the third minus 2x squared minus 3x plus 6. And I want to divide this thing by square root of 3. And this feels a little awkward to me. I'm not comfortable. I haven't had a lot of practice dividing with radicals. I can bring this down. I can multiply root 3 times 1, but then I kind of stare at this and say, well, what am I supposed to do now? Morgan, any thoughts? How do you add those together? I mean, it's synthetic division. I know I'm supposed to be adding these together. What do I get when I add them together? I'm going to get negative 2 plus root 3. And that makes a lot of people not very happy. So then I'm supposed to take this root 3 and multiply it times this. All right, well, let's think about that. What's going to happen when we do root 3 times this? Root 3 times negative 2 plus root 3, and I multiply, and I multiply, and I get negative 2 root 3, and root 3 times root 3 is root 9, and the square root of 9 is 3. And so when I multiply this times these and put the result up here, what I'm going to write is 3 minus 2 root 3, which makes people very uncomfortable usually. And so now I'm supposed to add these. Oh, well, conveniently, the minus 3 and the plus 3 cancel out. And so I just bring down the minus 2 root 3. And now I've got to distribute this times this. Well, root 3 times root 3 is root 9, or 3, and 3 times negative 2 is negative 6, and I get that 0 that I'm looking for. Ew, say I. What's that polynomial? Well, we know we started with an x to the third, so this has to be 1x to the second. And all of this has to be times x. Negative 2 plus root 3x. Minus 2 root 3. Most people are not comfortable with this at all. Oh, I'm glad you're doing that, Mr. Google. I don't want to do that. Okay, well, I hear you're suffering, and I know it because I'm doing it, but we also know from Jason that negative root 3 is a root here. And so I'm now going to take that 1 and do negative root 3. And when I add these, I get negative 2. And when I multiply these, I get positive 2 root 3. And I get my 0. And look what I'm left with. I'm left with x minus 2. So what do we know the factored form is? It's this x minus 2 that we've got now. It's this x minus a minus root 3. And it's this x minus root 3. Or, as Jason told us originally, x minus 2, x plus root 3, and x minus root 3. There will be times when you have to do your division with irrational things, and it's going to feel icky. But Ryan offers us a suggestion. Ryan says, look, if you know that x equals plus and minus root 3, that's going to give you x minus root 3, x plus root 3, or when he boiled it out, this. So here's my suggestion. Use this with long division. If you don't want to do these two irrational synthetic divisions, one after the other, use long division with this x squared minus 3. So what was our polynomial? 1x to the third minus 2x squared. Was it minus 3x minus 6? Minus 3x plus 6. That's the thing that I'm dividing into, and what is my divisor? My divisor is x squared minus 3. Now, this could be easier because I just have to multiply an x squared to make an x to the third. But I'm missing x to the first term here, and some people are uncomfortable with that. So let's explore what happens in this long division. What do I multiply this by to turn it into this? Just x. I distribute that x, and I end up with x to the third minus 3x. And I subtract. Well, x to the third minus x to the third, those cancel. Minus 3x minus a minus 3x. Well, minus a minus is plus 3x. Minus 3x plus 3x, those cancel. So all I'm left with is this and this. And then I say, okay, well, what do I need to multiply this by to turn it into this? And I say, well, a negative 2 would work very nicely there. Thank you very much. Negative 2 times x squared. Negative 2 times negative 3. And when I subtract, I get 0. Because it's untight. And so there we get the same x minus 2. And I guess, I want to say you should be comfortable with both synthetic and long division because there's virtues to each. I love synthetic division. It is so fast. But sometimes synthetic division is going to put me in a position that I'm not comfortable with, and I'd rather do long division, or synthetic division is going to put me in a position that I can't do anything with, and I'm going to have to do long division. So don't throw long division away, I guess is what I want to say. Any questions about this? Oh, there was a third thing I wanted to say. You guys are amazing factorers at this point. Can we factor this? How? By grouping. Okay. So we'll group the first two, and then we'll group the second two. And I can factor an x squared out of the first two, leaving the x minus 2. And I can factor a negative 3 out of the second two, and I get x minus 2. And then look, here's a common factor for me to pull out. And now I'm already at Ryan's. And then I could say, hey, look, this is a difference of squares. 3 is something squared? Sure. It's x minus root 3 times x plus root 3 times my x minus 2. And so my preference is still to do factoring first, but in tonight's homework, they're going to be explicitly asking you to do a lot of long and synthetic division. What I'm saying is, you can always factor to check your work. And especially on a quiz or a test, I'd be factoring, seeing what the answers are supposed to be, and then confirming it with my longer synthetic division. In the case of a quiz or a test, I think that makes a lot of sense to have that extra checking ability. I mean, when I think about this problem-solving plan of ours, examining the solution is something that I really want to take some time doing, and not just assume everything is correct. Okay, so any questions about long and synthetic division? Now we still need to get to number 3. Any thoughts about number 3? I got no thoughts. What strategy are you going to use, Alex? Couldn't hear you. Synthetic division. Okay. Will you do number 3 on your whiteboard for me? I'm not going to specify a method. In fact, why don't we make number 3 write the completely factored form. Most of the time when I'm doing my long and synthetic division, my goal is to get it into this polynomial into completely factored form. Five. 4. If we're going for completely factored form, the synthetic division of the long division is merely the first step we have to do. We would still have to break that down further. Yes. With linear factors. Completely factored with linear factors. minus 1, we've got x plus 1, we've got x minus 4, we've got x plus 1. Remember, we want linear factors. I did it first as a factoring problem. I factored the trinomial and got x squared minus 16x squared minus 1 and recognized that each of those are difference of squares. And so there's my factored form with linear factors. Then I went and I did it with synthetic division. And I got to x to the third plus 4x squared minus x minus 4. But then I realized that that could be factored with grouping. So I factored that with grouping. And I ended up with that x squared minus 1, x plus 4 that a lot of people did. Don't forget, this is a difference of squares. It's x squared minus 1, x minus 1, and x plus 1. And actually, don't forget the thing you started your division with, because if you only write down 3 of the factors, these 2 and this one, you haven't completely factored the polynomial. You're giving me a 3rd-degree polynomial, but we started with a 4th-degree polynomial. And I repeated the process with long division, and I definitely found that long division was a lot more writing than either of the other 2 methods. Any questions about any of the 3 approaches here? Okay. Last thing I want to ask about today is this. Can you please find this for me? Find f of negative 1/2 given f of x equals 18x to the third minus 21x squared minus 10x plus 8. Find f of negative 1/2, please. Problem's a lot harder, and you're much more likely to get it wrong if you convert things into decimals. No way. There's been too much rounding error there. Okay, so as I was walking around the room, most people were doing this. F of negative 1/2 equals 18. Negative 1/2 to the third, negative 21. Negative 1/2 squared minus 10 times negative 1/2 plus 8. And that's certainly to be expected. We talked about that in chapter 1. And so I have negative 1/8 times 18, or negative 9/4. And then I've got 1/4 times 21, which is negative 21/4. And then negative times negative is positive, and I get 10/2 for plus 5. And here I have plus 8. That's negative 30/4 plus 13, which is negative 30/4 plus 52/4, which is 22/4, or 11/2. To me, that's really time consuming to get the number 5.5. 11/2 is 5.5. So I want to do something that I think is really kind of stunning. An alternative to finding f of negative 1/2 that way is to do this. Let's take a look. I'm going to start with that negative 1/2, and I'm going to do synthetic division. 18, negative 21, negative 10, and positive 8. Remember how nasty those fractions were and how much we wanted to reach for our calculator and decimalize things? Bring down the 18, I multiply, I get negative 9, I add, I get negative 30, I multiply, I get 15, I add, I get 5, I multiply, I get negative 5/2. 16/2 minus 5/2 is 11/2. Notice, I don't have to play with all those fractions. I don't have to cube 1/2 and square 1/2. I just have to do synthetic division. Further, this. We know from Algebra 1 that we can write this statement, f of negative 1/2 equals 11/2. And this means there exists an ordered pair on the graph at x equals negative 1/2. The y value is 11/2. Well, look, I can get that same information from synthetic division with a lot less suffering. This is called synthetic substitution. I would ask you to put a star in your notes next to this, because on the test, I'm going to ask you to find f of negative 1/2, and I won't count it if you do it the Algebra 1 way, because I'm going to specify that you use synthetic substitution. Use synthetic substitution to find f of negative 1/2 means just do substitution, synthetic division with negative 1/2, and this remainder is the y value for this x value. And that's a second cool thing we get out of this. It's called the remainder theorem. So when you see the remainder theorem in tonight's homework, they're simply telling you that whatever the remainder is that you get, that remainder is the y value on the graph at that x value. I can find that y value on the graph by doing this Algebra 1 thing of plugging the function value in everywhere in the function, replace all the x's with negative 1/2, and simplify. Or I can use synthetic substitution to get there much faster. So you'll be asked to do some synthetic substitution problems tonight as part of the remainder theorem. The remainder theorem means whatever remainder you get, that's the y value for this x value. And then the last thing that we need to talk about today is what happens when the remainder is 0. What do we know about the y value at that x point? Angela? When our remainder is 0, what have we learned? No, not the y-intercept. The x-intercept, right. At this x value, this is the y value. At this x value, this is the y value. So I'm saying, what happens if we do our dividing and we get a 0 here? Well, when we get a 0 remainder, that tells us that the y value for the x value is 0, which means, Angela, we found which intercept? An x-intercept. And that's called the factor theorem. Factor theorem. When the remainder is 0 in synthetic division, your divisor is an x-intercept. If your remainder is 0 in long division, your divisor is a factor. Any questions? So we've got the factor theorem that says if you've got a remainder of 0, you found an x-intercept or a factor. We've got the remainder theorem that says your remainder is the y value at that point. And then we talked about how and when we might want to use long division and synthetic division. Any questions on this, guys? Any questions from the chart worksheet over the weekend? Yes. 3, did you say? Yes. Sure. Yep. Have a nice day, everyone. Tonight's homework is number 8. We said on Friday we're coming back to long and synthetic division today and finishing that. Tonight is 8. Over the weekend you had 9. And tomorrow we'll finally move on to 10. It's on the table. It looks like a chart. Some people do. Yeah.
Can you check some
Sure, but you know about the white binder to check your answers with? So you can always do that. You never have to wait for me. Hi there. You go to the bathroom. If you weren't here on Friday, there are 2 reviews to pick up. We are going to be doing stations today. Yep. Says so here. Thanks very much. That's what you can say about the change. I just have to. You've had stations for how long? Thanks very much. Okay. So, as we talked about on Friday, we're going to have our test not tomorrow, but instead on Thursday, the day